Okay, good morning, everybody. Thank you for those who have joined us online. This is the second of four parts of data management. For those of you who missed the first part, it's on our website, CUCMC Vellore. It's a YouTube channel. Just go to YouTube and search CUCMC Vellore. And there's a part one to this data management talk. So today I'm going to take the second of four parts. So the um, today is going to be a lot of for medical people who are not used to these words. Today's talk is going to be a lot about words, different kinds of words which are common for people who are data scientists and people who are doing data science, but not so common for medical people. So it's a little bit of non-medical words. So it's going to be a slow talk on a lot of technical words. So this is part of what I did last time, and this slide I've already covered in my last talk. The first thing when you're managing data preparation is what is your problem statement? What is the research question you're asking? And the main reason to say that is you must have some idea as to why you're looking at the data. That's the most important thing in looking at data is not the data itself. What are you trying to achieve out of it? And I've covered these earlier, is having a hypothesis or a problem statement. And you may have secondary hypothesis as well, like a primary hypothesis and a secondary hypothesis when looking at the data. If you don't have a hypothesis, then you may land up in something called data dredging, which is needlessly torturing the data till you find something. And this is a statement which was very often quoted. If you torture the data long enough, it will confess to anything. So we must look at large data. Sometimes people just look at large data sets with no idea in mind, but just looking for things. Again, these are slides which I covered last time. The next important thing is where do you get the data from? And there are major challenges in getting the right quality data to answer your question. So the data might not exist. That's one. Then you have to create data. The data may exist in a challenging format. For example, clinicians' notes which are written in hand and then scanned. It may be located in a workstation which you can't access. You may need some clinical expertise to identify what is DM, what is HT, what is SOB, shortness of breath. So there are many data elements which somebody may need. And you need analysis who can look at these and extract the data. So this is again a miss. I thought people would have forgotten these words. Query is to ask the database, where is the data? And this word ETL stands for extract, transform, and load. ETL data. So data warehouse I'm going to talk about today. SQL stands for structured query language, and often we'll hear this word in data management. So it's not unusual when you're doing a large research that you have to take data from many sources, not only the history and physical laboratory data, imaging data from radiology, echo data, which is like a different format. So different formats and different data. So to take it all from various original sources and put it into one source. So I'm going to use some words today, data mart and data warehouse, and I'm going to just explain that. Usually data is like thousands of rows. In a postgraduate dissertation, we collect 100 patients. Each patient is one row. But in a large project, it may be thousands. Big data is usually in the hundreds or thousands of data. So that's the difference between complex data. Okay, so all that I did till now was a reflection or a review of last time's class. This is new. So what is called a data mart? So take for example the first one here, which is this independent data. Let us say that you have history and physical from a doctor, we have radiology images, and we have ECG images. These are all different sources. So we extract, transform, and load it into a data mart, let us say a some data software which you have on your laptop. And from there, you take out the data into three separate parts for your analysis. Here, this is called an independent data mart because it is a standalone system. You collected the data. This is the data mart, and from the data mart, you're doing the analysis. So you collect data from various external sources, you collect it in a data mart, and then you do the analysis. This is called an independent data mart. The second one is called a dependent data mart, where you have data from various sources. It is extracted and saved in a large place called a data warehouse. And from the data warehouse, the data is taken for analysis. So this is called a dependent data mart. The third one is a hybrid, where there is two parts. One is data directly from the data warehouse and some data from the data mart. So these are the different words. Usually when you do large data, people in medicine will be confused. What is a data mart? It is just data taken from three different methodologies. One could be independent, dependent, or a hybrid method. The next new term to learn is called data lake. So what's a data lake? Now, the data mart, usually it's all structured data, meaning you know exactly what the data you're collecting. And then when you do the analysis, you know exactly how the data looks. The data lake sounds just like it is. It's just a central repository of raw data, which is unstructured or largely unstructured. Native format means in whatever format it was in the original, you just take it and keep it. So, for example, the data source may be structured. So, you know exactly what each data is. I'll talk about semi-structured means you know some of the data what it is and some of the data you don't know what it is or what the labeling is. And I'll give some examples of these JSON, XML in a little while. Unstructured data means just some data which you don't know what any of the data is labeled as. For example, video, audio files. You take all this data and you put it into something called a data lake. A huge, big, just imagine a lake where you throw all this structured, semi-structured, unstructured data. What do you do with this huge data lake, all the information? Then you start ingesting the data. Oh, I've got this large amount of data. I have to extract and load the data. It could be real time as well. This raw data is now transformed, extract, transform, when you want to do the analysis. So you keep it in this big lake. Only when you want to do the analysis, you transform the data, process the data, and do the analysis. So the data is stored in a huge unstructured format. Any format you take it and put it inside. So I'll just give you a slide. This one big example of a data lake is Amazon S3. And some of the software which or the programs used to analyze the data in a data lake, examples are Apache Spark and Hadoop. There are many of these, but just to get the medical audience and used to the word, there's something called a data lake where you just dump all a large volume of data, and whenever you want to do the analysis, you then transform the data and do the analysis. So, in a data warehouse, it's structured data, whereas a data lake can hold structured, semi-structured, and unstructured. The storage, the warehouse is optimized for your analysis. Whatever you plan to do, you store it in such a way so it's easy to analyze. But in a data lake, the data is stored in an unprocessed form. You can't, a data warehouse, you can't scale up too much. You can increase the volume of the data a little bit, but this is highly scalable. Cost effective because it is quite costly because you have to keep the data in a warehouse in the form that you want. It's a little costlier than just storing it in any format. So the data lake can be a little cost effective. Data processing, the data must be structured before ingestion. So you have to structure your data before you start using it in a warehouse. Here it's called schema on read. That is, you keep it on a raw form. When you want to analyze it, then you process it. So that's called a data lake. This is very fast. The data warehouse is structured for fast performance because it's all ready. Whereas a data lake is a little bit slower. So just to think about it, you collect data in a data lake, you ingest it, you blend it to whatever you want, you transform the data, and you publish the data, then you can distribute the data to various people. This is just a cartoon taken from this website Vector. This is a very nice article for somebody interested to read more about what is data lake in medicine, not general medicine, in medicine, by Tobias Genter and colleagues. So, for looking from a medical perspective, sources of healthcare records could be from patients, medical practitioners, hospital operators, clinical researchers, or even economic data like healthcare insurers. This Internet of Things, take a smartwatch, for example. The patients are interested to know that a real time, do I have an arrhythmia? And your watch can detect your data, and that patient data becomes a source for the data lake. But they're also concerned about the security. Hey, my data is being shared on the net. What about the security of my data? Medical practitioners like us, we want to query the platform. Let's say we want to ask our workstation, how many diabetics are there in our medical unit? How many of them had heart attack? How many of them had stroke? So we want to query. We want to visualize the data instead of large tables. If we can get graphs and figures directly from the warehouse. Sometimes we want to do data prediction. There is a publication from Vellore Institute of Technology in Vellore about a large prediction of heart disease, whether the patient is likely to have an MI or not. Taking a large data lake, they have looked at data, and you can use the data lake to predict whether you're going to have a myocardial infarction or not. Hospital operators, let's say you're the hospital manager, and you know how many beds, how many equipment should I order, how much oxygen do I need, what about patient flow, who has access to the data, social data analytics. We can look at the gender of patients, socioeconomic status, caste, color, religion. We can do some, so they may be interested to know some of these information. Researchers, which is a small part of this data lake, they want to query the platform to do research. Just looking at patterns or causal inference, is A causing B? Insurers also have their own take on this. Okay, this patient is likely to have disease, not have disease. What are his prior illnesses? So there are many people who need a data lake, and the data, and many people, all these data contribute into a data lake. So the use case is wide. Now, this is just a simple YouTube channel, which is really nice. It's called Technology for Teachers and Students. That's the name of the website. And in the talk which I would recommend is Intermediate Excel Skills Tips and Tricks Tutorial. So I would urge anybody interested in learning a little bit more about data analysis simply from Excel to learn to just visit this website. It's quite a nice website, a nice YouTube channel. Now, getting back to this data management and data analysis, this is a nice software called Open Refine. So you take messy data, you take a large volume of data which is semi-structured, unstructured, messy bit, and it will help you to fix inconsistencies, reconcile your data. You can undo and redo your whatever you do. There's a large amount of privacy built into it, and it's an open source software. It was started by Google. So cleaning large data set. So if anybody has a large data set and you want to clean it, this is a nice one called Open Refine. And there's a tutorial on the net, Open Refine Beginners Tutorial. So if anybody wants to try and look at a large data set and you want to clean it, that's a nice one. There is another one which is a very useful one for data wrangling, that is looking at data and cleaning it up and munching the data. It was called Trifacta, but the name has now changed to Alteryx. So there is a nice website which I've given here, the URL here, and you can try a free trial of a large volume of data. There's also a YouTube channel describing how this Trifacta works for looking at large amounts of data. Now, much of my talk has been modeled by on this book written by Robert Hoyt and Bob Munchen. It's called Data Preparation and Exploration. That is Robert Munchen. And there are many free data analysis programs. For example, we have paid one, SPSS, SAS, Stata. But these are free programs, and this website uh, lists them in order of usefulness. Jazz is a very useful one. Jamovi is a useful one. Blue Sky is excellent. This R Commander is an R-based software, which I'll talk about in a while. It is if you add the commander addition to that, it looks like a SPSS program or a easy to use program. You don't need any programming language. So these are some of the nice free software. I'll talk about them in a few slides. So what is this R program? So probably almost all the top universities in the West or even in the East now use this for data analysis. It's called R. It was developed quite a long time ago, and it's free to install for Mac, for Windows, or for Linux. So you just go to this website and you download the program for Windows. And then it's a little bit of a steep learning curve to learn this program. But once you learn it, it's totally free. You can do the best analysis in the world, right? So this is something I highly urge. And if you want to learn it, there are now so many YouTube programs how to learn R. You don't have to pay anybody. You don't have to go to any course. You can learn this R program by yourself. So this is an excellent one. Now that R has many add-ons to help you do this. So one of the programs which is added on to R, very commonly people use this program. You have to have R first, and this is called R Studio, and it's free to download. And again, there are many YouTube videos on using R Studio with R, and it's a fantastic program. So almost all the top universities in the world use R and R Studio. So it's also called an integrated development environment. Again, I told you today it'll be like an alphabet soup. So I had to learn some new words. IDE stands for Integrated Development Environment of R, which is this R Studio. Now, if anybody online, any of you guys are a beginner to data analysis and you're not sure how to do, download this program. It's called Jamovi. It's free. Fantastic one. Very, very simple to use. There are many, you can use it on the cloud if you don't want to fill up your laptop. You can just use your data analysis on Jamovi, or you can download this Jamovi desktop version. Excellent software, nice graphics, simple to use. So it's a nice program. Now, there is another programming language which many advanced statisticians use. It's called Python, and it's a high-level general purpose programming language. It's known for being simple, versatile, very easy to read, and there's a version called Anaconda IDE for Python, and there are two versions: Jupyter Notebooks, Jupyter Labs. So if anybody is interested, this is a very nice thing to learn. It's a little advanced, but for beginners, try the Jamovi one. Okay, so that was a bit of alphabet soup to learn some technology and words. Now we're moving on to another part called data preparation. So this is one of the most famous data scientists in the world. His name is Edward Deming. Uh, Apparently, after World War II, he was somebody who assisted the Japanese to rebuild their economy. And now, if you know, the Japanese cars are the most reliable in the world. So there's so many things about Deming. But regarding data, he made this famous statement: "In God we trust; all others bring data." So I mean, so not to make fun, but if you're doing research, it's the quality of your data that actually talks. He's a famous guy. So data preparation steps. So once you have a large volume of data, there are many steps to clean your data, that get good quality data and visualize it. This is called getting to know your data. So many people think this is the step of analysis and publication. No, the first thing is to just look at your data and get used to your own data. So when you select a data set, part one of my talk, I spent a long time on what is called data dictionary. I don't know if you remember data dictionary, that is metadata. What is the name of this data? What is the label of the data? What type of data is it? Is it qualitative? Is it quantitative? Is the data coded? What is the purpose of collecting the data? So that is called data dictionary. So any good research scientist must create data dictionary. This data dictionary gives you a background and context about your data. People also call it metadata, but otherwise you don't know what the data is. It's some sort of weird data which you don't know why it was collected. So always have this data dictionary. Again, please refer to the first talk about data dictionary. So what are the 10 steps when you have data? First, you have raw data. You have to collect some data. You're a postgraduate, you're a faculty, you have to collect some data. Second, you must know what format your data is. There are many formats, and some of my talk again back is going to be about different types of data formats. Then you must inspect your data. Oh, this is what my data looks like. Combining data sets. Okay, so you've got data on history and physical from one source, the image data from another source, the lab data from another source. So you must learn how to combine data sets. Reshaping data sets. I'll talk very briefly about reshaping data sets. Then you start descriptive statistics. Oh, how many men, how many women, what is the age structure of patients, how many have comorbidities. That is descriptive statistics. Then you do data visualization. Let me have a look at graph. What should I do in pie charts? What should I do in histogram? What should I do scatter plot? So that is data visualization. Data cleanup. Oh, I realize now that there are many missing data, wrongly coded data. You start cleaning up your data. I'll talk about data leakage in the next talk and about handling missing values. We'll talk about that in the next talk. All this starts before doing analytical statistics. So these are the initial steps that any researcher must do when you get some data. So there are 10 steps. So I'm going to just talk about some of these steps today, and the rest of the things will be on a subsequent Saturday. So the first one is raw data. Raw data are thought to be messy. Lot of errors are there. You collected some, instead of height 20, you put 200, or instead of weight 30 kilogram, you put 3. Missing values. The outcome is mortality at 6 months, but for 20% of patients, you have no outcome data, missing values. Omissions. The gender data was available in the record, but we forgot to put it. We just forgot we were doing data entry. Inconsistencies. Well, you must check for inconsistencies such as 3 women were found to have prostate cancer. Oh, that's a data entry error. There are other inconsistencies. Somebody's age is 69, but doing data entry 6 and 9 keys are very close because entered as 96. So these are data inconsistencies. Suddenly, oh, I've got a lot of old people, but actually, I don't think I really have that many old people. Inconsistencies. Then you must extract the data from wherever it is. It may be in a spreadsheet, Excel format, and then take it to your computer. So when you extract the data, you're just taking the data from a source and keeping it with you. At that time, there's no cleaning, you're not doing any error correction. When you take the data, let's say you take it from a hospital workstation or electronic medical record, initially you just import it to your software. At that stage, there's no cleaning going on. The early stages after that is examining and cleaning the data. And one of the things that when you do cleaning of the data is what type of file type I have. And that sounds confusing. As doctors, they're only used to Excel data sheets. But there are many types of file structures. And we have to get used to this as healthcare professional. How do I take that different types of file structure for my analysis? So the next few slides, I'm going to talk about different types of file structure. So usually in Excel spreadsheet, we have data in columns and rows. These are called columnar or tabular data. So the first one is file formats which are delimited. Delimited format, the first example, most common is called .csv. Excel spreadsheet itself, you can save it and you can save it as a CSV file. Many software need the Excel software to be saved as a CSV file, then only they'll do analysis. So you can see here, each row represents a record or a patient. This is patient 1, patient 2, patient 3, patient 4. This is called a record. Each record contains fields. So each of this data is called a field. And they are separated by a comma. So I was just looking at withdrawn papers from India, from PubMed. I was doing some analysis. And 2025 is the year. In 2025, 14 papers were withdrawn in PubMed. In 2024, 85. Usually we're used to seeing each of these in a separate column in Excel spreadsheet. But in the CSV format, they're separated by comma. So this is called comma separated values. It's a common type of data. The disadvantage is in the new Excel spreadsheets, we can have many workbooks in one. Workbook 1, 2, 3. CSV, you can have only one. And you can't put formula on that. Sometimes in Excel itself, you can do the splits. You can put a formula in an Excel box, it can drag and do formulae from height and weight, you can make it BMI, and you can look one file BMI and get a lot of BMIs out of that. Now, let us say that somebody entered the data 1000. What will happen? It will take it as one, and the next zeros will go as the next one. So if you have data like this, you have to put the data in quotation marks. Then the software will understand like this. Or you take out the comma. There are many programs which will get rid of all these commas when you want to get rid of them. Otherwise, it will think of this as two separate data. This is called .csv, comma separated values. The second one, you'll find that many data come as .tab, tab separated data file. So the text files contain list values, just like CSV, but when you have it on your keyboard, we have tab. So after you put one data, you put a tab, it moves a space. So these data are separated by a tab or a space. It's similar to CSV files. One record per line, that means each line is one patient, and as a tab between each field. You can import a tab.tab file. Suppose you find somebody sends your data, it's in .tab. You can just import it into Excel. The next one is called a data file. When you look at the file, it will end with the suffix .data. This is used by one software called Analysis Studio, initially by IBM, now used by many other people. It contains mined data, that is, you took data from various sources. It's a plain text, so the data is in plain text, and tab delimited. That means the data is separated by a tab. Many data repositories come with this. So you can download data from the web. It will often come with .data file. You can't directly use it to analyze. So what should you do? You have to convert them to a common format. All you have to do is take the data, save it in another place, and change the text suffix to txt. That's the first thing to do. So the file will come as a .data file. Just change the suffix to .txt and then import it into Excel. That's the workaround. If somebody sends you a .data file, you change the suffix to txt, import it to Excel, and then you can export it in Excel itself to a CSV file or any other file that you want for analysis. Now, just a little bit of a aside. This guy, R.A. Fisher, is the father of modern statistics and biostatistics, Ronald Fisher. And he was a botanist and he was working with plants. So he was working on a type of plant called the iris plant. And he created a data set of 3 classes of iris plant. And he loaded this website, he gave his data set free for people to learn. So there is this data set which is available free on the net. So if anybody wants to take a free data set and then try to do all tricks with data, somebody's free data, how to analyze data. This is a nice data set which is available. I've given the UCI link to get this data set. Okay. So you'll have in that, why did I mention this? You'll have it comes in a .data file. So if you try this, what should you do if you download .data file? Change this to .txt, import it into Excel, then you can change it to CSV or whichever file you want. So there are a lot of data which is available in this data set. Just to teach that there is a data set and you can use this .data format. Now, when I was studying, all Excel spreadsheets ended with the suffix XLS. And this was there from 1997 to 2003. So if you save an Excel spreadsheet, it gives an option to save it in this older version of Excel. That may sound ancient, like prehistoric, but many data sets are saved in this older format. So why should you know about this older format? Because it's the predecessor to the current version, which is .xlsx, which is Open XML Spreadsheet. XML stands for Extensible Markup Language. Again, this may sound why are we learning this, but when we start doing more data analysis, we are going to get all these files. People are going to use this jargon. A lot of AI is coming up, and people will use all these words, and then suddenly it's not be like Greek and Latin. So this current Excel spreadsheets use this new version, Excel SX. It contains all information in a workbook. So you can have formatting, charts, images, formulae. So the new Excel spreadsheets are very powerful. You can put formula inside, you can create beautiful graphs and pictures and complex data. So if at all possible, if you're using Excel spreadsheet, save it in this version. Somebody makes you the older version, save it as a Excel SX format, not the older format, which is .xls. So you must always try to save your Excel spreadsheet data in this newer version. Now, another one, JSON, which stands for JavaScript Object Notation. I don't know if you remember a few slides ago, I showed you a data lake. Some data is in weird formats, and you just chuck it into this lake. Very often, that data is a JSON file, which is JavaScript Object Notation. So this is for structured data. Structured data means you know what each data heading is. This is age, this is gender, this is diabetes, this is hypertension. And it usually this JSON format is used to transmit data between a server. Server is where the data is kept, and the web application. Let us say that the data is weather, and there's a weather data in Indian government website, and you have a web app. On our phones, you can often find today's weather is so much. How does your phone get that information? Data from the server comes to the web application through a JSON format. It is an alternative to XML. So that is a little bit about JSON. Database file. Now you have a large database. You are saving the data in a computer called database. So some of them are structured data. So structured data, again I explain, it has a structure to it, and you know exactly what each data is. So why is it good to be structured? For storing, it is efficient. For retrieval of the data, you can retrieve what you want, what you don't retrieve. And management. There are some specific file formats for database files, and we must get used to these technical words. MDF stands for main database file. .ldf, sorry, .mdf. .ldf is a transaction log file. I'll explain that in a second. Now, SQL I explained earlier. The data can be saved in a SQL server. SQL servers capture structured data. So somebody says, I have a database file. It is structured. Most likely it is called SQL server. But you can also have non-structured data, and that is also often referred to as NoSQL file. One example of a NoSQL file is called MongoDB. Just to know that where this data are often saved, it could be a structured or unstructured one. So what is .mdf? That is the format for storage of the data. So the data is stored in your database in a .mdf. But when you want to do some transactions with the data, when you want to transmit your data, that is the .ldf. It records changes and transactions. So if you have a large file, large data set, many files, how does the software work? How does it manage the different files in a database? So there's a database file system, DBFS. So it's an implementation of a file system within a database. So you can create and manage your files in a database. Okay, so this is a mouthful of few words. It's basically we have large data management or a data file. These are the words which computer people use. Increasingly, as doctors work, we have to work with computer people, with data scientists, with statisticians, because they're going to analyze large volumes of data, and we need to understand what they're talking about. Now, web-based data. So there are vast amount of information exchange on the internet, and we are often familiar with Google, which crunches a large amount of web-based data. Access to online data with a simple download. How do you do that? There's something called, last time I talked about, it's called Application Program Interface or API. So let's look at this API. This literally scrapes the data from the internet. So let's focus on the picture below first. That's you there. Let's say that is Anuka. She's ordering a coffee, and then she tells the waiter, I want coffee. Waiter goes to the coffee maker, coffee master, and then the coffee master makes the coffee, brings to the waiter, and delivers to Anuka and me. This is the waiter is the API. You, let's say Vineet is here. He requests the web, I want such and such data. The API or the waiter goes to the web, to various servers, gets the data, takes it back, and gives it back to Vineet. This is called the API or application program interface. So, for example I gave you apps. How do they get information? The weather app connects to a weather service, Indian weather service or some other global weather service. So, in a real time, you're getting today's weather in your place. You travel somewhere else, you give the weather in that place. So, those are the things, an example of an API. It just helps you to do that in between part. So, this is API getting data from the web. It's an in-between part. You are here and the web is here, and this is the API which is getting the data or scraping the data and giving you the data from in between. So now let's talk a little bit about web-based data. So what are the different types of web-based data? First, I told you structured data, organized, easy to process. Somebody has already kept the data clean and neat for you. So it's very nice for you. You just have to take it. Structured data, it's saved in tables, formats, spreadsheets. Usually, like for example, economic data or billing data, it's all structured and kept there. So product listings, customer data, website metadata are structured data. Totally unstructured data. On our website, we have media posts, emails, video data, audio files. We don't know what it contains. This is totally unstructured. Semi-structured means there are some part of the data which is structured, some part of the data that is unstructured. Again, I just want to get people to get used to this idea. So I told you that example of JSON or XML files, they use for semi-structured data. Then we come to behavioral data. So, for example, they can see, let's say, a website. They can see which websites you're clicking to. So people are there who are tracing out each human being, where do you go, which 5 websites you click at. They're analyzing that as your behavioral data. It's strange to say, it sounds creepy, but actually people are there who are collecting such information, click stream data, navigation pattern. What are the websites you are searching? We've all seen that. You simply search for some shoe online. Next thing in inbox, you suddenly get mysteriously some free shoe ad. How did they know? That means that Google sold that to a shoe company. The shoe company decided to got your email address and mailed you. So there's a definitely so behavioral data is being collected in a large amount. Transactional data. So every time you order on Zomato or Swiggy or whatever, Flipkart, anything, there is somebody who's collecting that information about you and what transactions you have made. That is called transactional data. Sensor data. So, for example, web, for classical example, your smartphone or your smartwatch collects data. I can be surprised. Your smartphone, if you put the health app on, It will tell you how much times you walked in a straight line, how much time your gait was unstable. So it's collecting all this information about you. How does it know when I slept and when I didn't sleep? But someone's able to give a reasonably accurate information about all these things. And that is what people call as Internet of Things, because the sensors are connected to everybody. Weather data, traffic data, environmental monitoring, all these things are they're called sensor data. Geospatial data related to GPS, we all know, global positioning system, applications that track movement. So this data is also widely available on the net, GPS data. Publicly available data, for example, open data sets. There are many people who do research and will say that I want to share my data with anybody in the world. Just go to this website, you can download my data with a dictionary to know what I did. Government reports are free. Educational resources like RCU, YouTube, is a free resource. There are publicly shared social media profiles. So there's so much information which is free. So all these are called, sorry, I just put the heading again, web-based data. So people think, what information can I get on the web? You will be surprised what a mountain of data people can get on the web, right? Okay, next. I told you about web scrapers, API. So these are also called data miners. Mining is like going and digging for gold. And they pull a variety of data from various web pages into a CSV or XLSX file. These are the two Excel spreadsheet types. So one example of a free data miner is this one, which is called dataminer.io. So you can try this one, and it gives an easy workflow how to get data from the internet. But many people use these kind of data miners to get data. R, I told you, is a software. R is like a program where you can do many analysis. And let us say that Reba gets a new she invents a new program. Okay, this is how I analyze this new type of data. You put up your software on the net into this R cran or R library. Anybody in the world can say, but your name will be there. Vinith can download your program and analyze his data using that. So everybody in the world who tries invents new statistical programs, they upload it onto that R library, and anybody in the world can download that program free and analyze data. So it's like a living software. Every day it's being updated. And so that one such R function is called read CSV function. And if you have that in your R, it can read data sets directly from URLs. URLs is the web page link. There's another R program called RWest. These statistical programs in R are called packages. It's another popular web page for scraping data. And it looks like this. You just have to go to the net. You have to install R software in your laptop. Then you go, there's a methodology for freely downloading new packages. So you say, hey, I want this package. Go to the net, download the package, you have the data, you analyze the data using it. So this is a package called RBest. And that's the link for this RBest. Python. Python is Snake, but it's also a programming language. In Python, there's a package called Pandas, which reads HTML files. And in that, there's a package called Beautiful Soup. Now, this again, I told you the alphabet soup today. But just to understand, I want to scrape the web for data. I am familiar with Python. In Python, you have to download this program called Pandas. And there's another version, a thing called Beautiful Soup. Don't get confused by all this. Someday somebody will say, I use Pandas, Beautiful Soup. What did you do? I scraped the net for data using this Python program. That's all. And I've given the URL link for these. Now, some more soups. ASCII tool. When a computer talks to another computer, how does it talk? Does it use English? Does it use Roman numerals? How does it talk? So that is called this ASCII. Encoded standard. So between computers on internet, the first version was called ASCII or AS, the ASCII character set. American Standard code for information exchange that is called ASCII. It started in 1960s as a character set for computers and electronic devices. So there's ASCII 7. It's a 7-bit character set and has 128 characters, numbers 0 to 9, and upper and lowercase English letters from A to Z. That's how earlier computers talk to each other, and some special characters. So in HTML on internet is largely based on ASCII. It looks like this. We don't have to go into it, but it's just like a language for computers, one computer to speak to another computer. The common older language was called ASCII. It's a text format and it is commonly used in the US. It was earlier used in the US. In Europe, they wanted to use a different standard. And the different standard was called Unicode. So the earlier one was called ASCII. Now the current one is called Unicode. In the 1980s, it was started and it's called Unicode Transformation Format or UTF. So currently, there are all computers use this UTF format. There's UTF-8 and UTF-16. And you can convert the earlier ASCII text into UTF-8. So somebody has ASCII base, there's a software which will convert it to UTF. So this is how the UTF looks. It looks much like this Egyptian hieroglyphics seen in the pyramids and stuff like that. But it's a character encoding standards for electronic communication. It's an 8-bit version. Most web pages use the UTF-8. And it's backward compatible with ASCII. So in other words, if you have UTF-8, an ASCII will work on it. All countries and languages on the internet generally use this, and it has 99% global coverage. And it is supported by all operating systems and programs. So we may just get used to this word. There is something called UTF-8. I'm coming towards the end. Here's an example of data sharing. I just wanted to get an example from India. Not from India, there's an Indian author, T.V. Shekhar. The impact of self-report versus objective measures in cardiometabolic conditions in epidemiological research. It's a mouthful. A case study from India using data from the longitudinal aging study. So this is the study, longitudinal aging study. And they've taken the data, not web scrape, they've taken the data and published the data. It's published in Frontiers of Epidemiology just last month, July 2025. And they made a statement. Data from this is publicly available in this website. So anybody can go to this Gateway to Global Aging Research, go to this website and download all the data from this project, and you can reanalyze the data and have a look at it. So I simply went to the website, and in the website they have an interactive graph. So I chose China, and I took 1994 to 2018, and I looked at health, and I asked the measure ever had diabetes. And the website produces graph for me. Ever had diabetes in China in 2010 was about 6 or 7%. And right now it's in 2015, 16, it's about 9%. So this is an advantage of if you share your data, other people can analyze your data. And there's so many data sets freely and widely available. Okay, so that brings me to the end of today's talk. It's just a continuation of the first time's talk was a little bit about data, types of data. I also talked about data dictionary. So today was a little bit different. If you have raw data, what are you going to do about it? And I know I spoke a lot about different funny words, but just go back and look at it. You get data from various types, file structures, just to get a medical person a flavor of these things. If you want to read more about it, you can go and read, but this is just an introduction to different types of raw data. Next time, we'll go into combining data sets and you get data from various sources, how to combine them, and slowly we'll go into more advanced parts of data. Okay, so any questions?